Good morning, everyone. Welcome to the webinar of boosting product development process using SolidWorks Simulation. I am Gaurav Patel, working as a simulation engineer in engineering technique, which is a well-known reseller of SolidWorks product. Okay, let's start with the objective of the webinar. Uh, in the fast-paced world of product development, time is of the essence. To stay competitive in the global market, Indian company must bring their products to market very quickly and efficiently. SolidWorks simulation portfolio facilitate any CAD engineers with the advanced technical tools to stimulate the product development process. Okay, let's start with the agenda of today's webinar. We begin with the basics of the product development process, then concepts and need of the simulation. Then we learn the science behind the simulation. It is FEA, that is finite element analysis. Then we are going to see the static simulation analysis process. Then various assumptions that are considered in linear static analysis. Then we understand the process with a case study, and after that, I will show you the demonstration of a particular product, and at last we summarize the webinar. Okay, let's begin with the product development process. So, what is product development process? So, for any company, the main objective is to sell a product in the market. Okay, so before going to the market, the product must pass through various stages. Okay, so these stages are the product concept or say project concept, then product design, then which is followed by prototyping, testing and validation, and at last the production. Okay, now the product manufacturing start with a product concept, that is the idea, which idea is converted into the product design, which is on paper. Now as the product design is finished, the product is transformed into the physical product by various manufacturing process, that is called as a prototype. A prototype is tested whether it is fulfilled the design criteria or not. Until and unless the prototype fulfill the design criteria, it will not forwarded to the production mass production part. Okay. So what happened? Okay, this is the major part that consume the product development process. This is the traditional development process. Now, the modern product development process is a mod-sim driven product development process, in which the prototyping and the testing is validated within the computer. Okay, so how the product development process is changed, though it is start with a but obvious with a concept, but instead of the paperwork, the product is modeled within the computer. Now, modeling is a new terminology which is generally used at the present day in CAD/CAM area. So basically, mod stands for modeling. That is the computer-aided design part, and C stands for simulation. That is the CA part. Okay. So until and unless the product fulfill the design criteria, uh, then the prototype is manufactured at last, and then it is tested only once. Then whether when it is fulfilled, then it will go to the mass production. Now if you can see the with the help of this process, you can shorten your product development cycle. Okay, so as I told earlier, the in this fast phase of the product development process, time is the money. Okay, so we can save the money, or we can earn the profit by using the machine driven product development process. Now, there are various drivers which drives the product development process. Okay. Now, every industry is transforming to harness digital technology to meet the demand of discerning customers. Okay. Now, in this digital age, connected consumer have come to expect enriching experience. To deliver this experience, business need to develop intelligence and autonomous products. They are also leveraging data as a strategic asset to provide value-added services. Okay. Oftentimes, this means adopting new business model and breaking down operation silos to improve agility. Okay. So there are many drivers which drives the product development process. Some of them is performance of the product, then the strength of the product, then noise, material, innovation, then weight of the product, safety, quality issues, cost, okay, eco-friendliness, then time to the market, manufacturing technologies, advanced technologies like 3D printing, heating, cooling, energy saving, regulations, vibration, and at last the connections. Okay, so there are various drivers. Now, by using the simulation, we can increase the innovations, then we can increase the performance, optimization of the process and product, and CAD engineer can raise his confidence. Okay. Now, what the parameters decrease? Then cost is decreased, but obvious production cost or development cost, then time to the market is decreased, then product failure can be reduced, and risk of the product is can be decreased. Okay. Now, let's understand the concept and the need of simulation. Okay. So, as shown in the product development process, the prototyping and testing is done physically in traditional thing. Okay, in modern driven product development process, it is done within the computer. So we can say that from the CAD perspective, simulation is considered as a virtual experiment. Okay, so it is a phase inside the design process to test product performance and behavior virtually for a wide range of real physical scenario. Okay, these scenario are listed down here. That are structural, then fluid dynamics and heat flow, whether plastic injections, motion, and the combination of these things that are called as a multi-physics. Okay. Now, simulation impacts on very much parameters. But for the simplification, I will take the three basic parameters on which the simulation make a major impact. Okay, and company focus on that impact. The first parameter is the cost. Okay, so the demand to reduce the cost never goes away in any company. Okay, the objective could be to reduce operation cost, manufacturing cost, prototyping cost, and more generally to manage the budget. Okay, this means that the company has to find a way to reduce cost while simultaneously working for the growth. Okay, integrating simulation inside the design process helps to develop a cost reduction strategy that maximize efficiency without compromising growth potential. Okay, so basically when you are considering the manufacturing, you will try to reduce your energy cost or material cost or optimize the product process. And when you are on the shop floor things, then you need to reduce the costly prototype and the outsourcing cost. Okay, so this is the major parameter which affect the by the simulation. Okay, now quality. Okay, so every company improve the quality at a and reduce the price. Okay, So what happened by using the simulation, we can improve the product quality. How? So we can produce the reliable product at a shorter cycle time. Then we can filter out the design weaknesses. Okay, by using the various structure simulation or say flow simulation. Okay, and we can enhance the product life. Now the third parameter is the time. Okay, so by using the simulation, the project length is drastically reduced as the experimentation is done virtually. Okay, so the other parameters are quickly check the multiple design. You can check the various design and compare which are the best design among them. Then earlier detection of potential issues. Okay, you can uh, directly predict which are the uh, bottlenecks in the designs, and you can enhance the design from the simulation, then reduce trial and error process and reduce time spent on the head calculation. Okay, so by using simulation, the cost can be reduced, time to the market can be reduced, and quality and performance is can be increased. Okay, so basically now companies are constantly looking for ways to streamline operation and increase the efficiency, but without sacrificing the quality of their products, which is delivered in the market. So integrating simulation into the design process helps the company to improve process efficiency as they can perform in-house performance and quality testing without relying on the external third party. Okay, so simulation is then a fully embedded step on their product development process and helps to optimize their products. Okay, now if we can see the current market trend of simulation, it is continuously growing. Okay, so the market trend is have never been the stronger than before for the simulation due to the several convenient environment factors. Okay, so using you can see there are few products available before 10 years and 15 years, but instead of that now the number of products are available. You have several options. So to remain competitive in the market, you must follow the simulation process. Okay, the product development cycle is now become very faster. We can see every month or say every week a new product has been launched into the market. Okay, then less physical prototype. That is the another factor. Innovate more to stay competitive, fast decision making process. Then to ensure the customer satisfaction, every company needs to increase their quality with the less price. Okay, and to reduce the product recalls, the simulation can act a major role. Okay, now let's understand the science behind the simulation, that is finite element analysis, that is FEA part. Okay, now uh, to understand very easily, I have taken one example. Uh, Suppose this is my home and this is the way to the mailbox. Okay, so it is a curvilinear path. So if I want to measure this path with my meter tape, how can I measure? Because meter tape is a linear path. Okay, so what should I do? So I will break this part into small component, small finite component, and that component is known as an element. Okay. So basically, to measure this part, I will measure this linear distance, then again the linear distance, and I will add up this all at last. Okay. So after addition of this all linear value, I will get the approximate curvilinear value. Okay, so this is the basic concept behind finite element analysis. Okay, so similar concept will apply to analyze any product, any product or say concept or design. Okay, let's understand the various elements that are used in finite element analysis. So basically, the main elements are mesh elements and nodes. Okay, here you can see this is the a particular design or say concept. Okay, so what is mesh? So you can see here it is divided into several smaller parts. Okay, so it is the mesh is the approximate representation of the CAD geometry using various elements, say tetrahedron or say triangles. If it is the 2D shape, then it is a triangle, and if it is a 3D element, then it is a tetrahedron. We are going to see in forthcoming slides that how many types of elements. Okay, so what is element? So you can see at here the shapes. Okay, so they are the elements. And what is nodes? The point at which the different elements are joined together. Okay, and nodes are the junctions or say locations where the value are unknown. Okay, usually in structural analysis we term as a stress or say displacement. Okay, strain can also be find out, but at their nodes we are calculated that value. Okay, now let's understand the different type of 2D elements. 2D elements are generally divided into two parts, that is that is triangle part, and quadrilateral, that is the rectangular part. 1D, one can say why so is not explaining the 1D element. 1D elements is generally the linear part that we already discussed in this thing. Okay, so 1D element is called as a line or say beam. Okay, the 2D element mainly are triangular part and quadrilateral part. Now, here in SolidWorks, there are two type of 2D elements is considered. One is the linear part, that is the L3. So you can see there are three elements connected by three nodes. Okay, so that is the L3 part. And if you put the three additional nodes in the center of this element, then it is converted into the parabolic elements. Okay, now when it is the linear element is deformed, then it deformed linearly only, and the parabolic element is deformed curvilinearly. Okay, now same as in quadrilateral L4 and P8. Now, different type of 3D elements are, it is the tetrahedral that we have discussed earlier, then penta or say beige elements, the hexahedral, that is the brick element, and another type of element is pyramid. Okay, similarly in the 2D element, if we put the different node at the center, then it converted into P10, P15, P20, and P30. Okay, now how we can building the FEA model. So in this thing, in this slide, we are going to understand how the FEA analysis has been done. Okay, so similarly, we have a CAD model. Okay, and by applying the FEA process, we got the result. Okay, like in form of stress and strain and deformation. So suppose this is our CAD geometry. Okay, so before starting of the 3D simulation or say structural simulation, we need to process this CAD geometry. Okay, so there are several say methods by which we can apply this process. One of that is called as a defeaturing part. So if you can see, this geometry has a various feature like fillets and small chamfers and all that. So they are not make any impact in the simulation. So to simplify the simulation, what we have to eliminate this small roundness and thickness, say chamfer and all that part. Okay, So external fillets, rounds, logos, and other elements are removed in the pre-processing thing. This process are called as a defeaturing. Then after that, we can use idealization. That means it is the more aggressive exercise that may depart from the CAD geometry. Suppose the representing thing was within the surface. Okay. Now another thing is to clean up the CAD models. Okay, the overlapping edges and surfaces that we need to clean up before the simulation. Otherwise, it will create difficulty in the simulation. Now, this is the CAD pre-processing part. Okay. After completing this all process, what we need to do, that is the FEA pre-processing part, in which we are deciding which type of analysis has to be done, then which type of material from product has been made, then various support its load that we are going to apply. So what we are basically doing, that we are transforming this CAD model into the mathematical model by which we can get the output. Okay. After completing this part, in pre-processing, what we are doing, that we are meshing the product. So this process is called as a discretization. So what is discretization? So we are dividing the working domain, which is a part in simulation, it is called as a working domain, into small geometrical entities. Okay, and after completing this meshing, the numerical solver has been applied, and that is the processing part. Then we run the simulation, and at last we get the result. Result that we get as a post-processing part. Okay, so this is the way by which we can building the FEA model. This is the process. Okay, by which we can get the result. Okay, now when we are talking result, we must know what are the different terminology that are using result. Okay, so as highlighted here, it is a stress result. So we are discussing the stress part. Okay, displacement that we are generally measure in or say micron part, but the in stress part there is a one popular terminology. This is a von Mises stress. So what is von Mises stress? So basically, the von Mises stress are equivalent stress, and which is independent to the coordinate system. So you can see here the Sx, Sy, and Sz are the principal stresses, which are generally act as a normal stresses. Here you can see that is the P1, P2, and P3. Okay, here it is written as a Sx, Sy, and Sz. And the three shear stresses, either Xz or Xy, then T and Tyz, or Tzx and Zy. Okay, so by using the six quantity, that is the three normal stresses and three shear stresses, the one Mises stress has been calculated with this formula. Okay, now uh, let's understand which are the basic assumptions that are considered under linear static analysis. Okay, so in linear static analysis, it is considered that the response is proportional to the applied load. That means if you are double the load, the deformation is also getting double. Okay, and when you are removing load, then the model comes to its original position. So there is no deformation in the model. Okay, now when the material is linearly elastic, that means when you are removing the load, it get is in original position. There is no permanent deformation is allowed. Okay, and the load are considered as the static. That means the loads are applied very slowly and gradually. Okay, rapidly applied load cause additional displacement, stress, and strain. Okay, now to understand the simulation process in SolidWorks simulation part, let's take a case study which is carried out by our ex employee. So before taking the case study, just I want to brief the simulation interface. Okay, so you can see here, similarly as the SolidWorks output, uh, this is the study tree in which you can apply the various boundary condition, the loading condition, type of study, forces that are applied, meshing parameters, and you can see the post-processing part also in the result. Okay, this is the command tab by which you can give the command. Okay, the toolbar which can be derived from the command tab manager, the study tab which will show in which tab that you are currently working. Then the simulation advisor, which will help you in the simulation process, and the analysis library, in which you can assign the various material also. Okay, so this is the basic of GUI of SolidWorks simulation. Okay, now let's take a case study to understand this process, how it is actually going on. So for that, we have taken the assembly of this loader part. Okay, so if you can see, the loader is fixed at here. Okay, you can see at here. Okay, these are the two loading arms, and this is the bucket by which it can load the various mixtures in this mixture part. Okay, so the first part of the simulation is to apply the material. Okay, first we need to define the study, which type of study is that. So we already defined it is a linear static study. Okay, after the definition, study definition, we need to apply the material of the various components. Okay, so here the material is applied as a steel Selma 350, steel EN, then steel 250 BR, and various parameters of the that particular material is enlisted here. Okay. After applying the material to the different components, we need to provide the different boundary conditions. So that is a part of pre-processing. So here we apply the fixture part. Okay. So fixture is necessary. Otherwise, when we are applying the load to a particular geometry, it will move in the space. Okay. So and it will not say converge. The solution is not converged. So what we need to do? We need to provide one restriction. So we need to fix that part. So it will deform accordingly. Okay. So you can see here in this GUI, there are three types of fixtures are available in the SolidWorks. That is the fixed geometry, roller and slider, and fixed hinges. Now, how this is decided? This is depends on the degree of freedom of a particular product. Now, you must know the degree of freedom as you are engineer and you are designing the various components. So, degree of freedom is the unconstrained motion of a particular of a product, or say geometry. Okay, so when you are restricting this all degree of freedom, then it is a fixed geometry. When you are constraining or you are freeing only linear motion, then it is called as a roller or say slider fixture. And when you are freeing one rotational motion, rotational degree of freedom, then it is called as a fixed hinge. Okay, you can apply at any vertex, any edges, or any faces to the component. Okay, now after defining a particular fixture, what you need to do, that you need to apply a loading condition. Okay, this is the another boundary condition that you must use in any simulation, any structural simulation. Okay, so here the gravity load is applied, the digging load is applied, the generally load is applied normal to the boundary. Okay, it is not true every time. You can define as per the actual scenario. Okay, and the side load is applied at here. Okay, the load in terms of forces, torques, then pressure, various type of load that you can apply. We are going to see in demonstration how many type of load that you can use. Okay, and we need to use the magnitude of that load. Okay, then the other part is the meshing part. Okay, so in meshing, what we are doing that, as said earlier, we are discretizing the domain into smaller features. Okay, so there are three type of mesh available. That is standard mesh, curvature based mesh, and blended curvature mesh. Okay, so these are the various parameters that we are going to learn in demonstration. Okay, after applying the mesh, you need to run that study, and it will provide you the various outputs in terms of stress and displacement at the end. Okay, and you can observe these things, and you can interpret what can be happen in the actual scenario. Okay, now let's understand the process by this demonstration of the simulation part. Okay, देखा है? ये देखा तो? Just give me a second to share my screen. Okay, so what I'm doing that I have taken one geometry, one part. This is the part. This is a design tree by which you can create the part in the SolidWorks. Now, to simulate this thing, first what we have observed that we need to pre-process this CAD geometry. So what we need to do that we need to remove this fillets part, all fillets and rounds and chamfers. Okay, so what I have done that I have created another configuration without the fillet. So before that thing, I'm going to activate that configuration. Okay, so you can see here the fillet at the all ends are removed. Okay, now to start the simulation, what I need to do that I need to first define the study. Okay, so what I am doing that I am creating a static study. Okay, so you can see here this is the study tab. Okay, by which you can define different type of study. We are going to see the linear static study. Okay, so I am defining the study as a linear static study. Okay, and I have to just click OK part. So you can see here the simulation tree is open up. Okay, now uh, you can see here the configuration is without the fillet. Okay, now what we need to do that we need to provide the various properties of this study. So you can see here the solver is considered direct automatically. Okay, so you can use the manual solver according to the simulation environment. Then the various manual solvers are HAP Plus, Intel Direct First, and large problem Direct First model. Okay. Now the other parameters that we are not going to discuss. The adaptive thing that we are also not discussing because it takes too much time. Okay, so we just decide the automatic and we go ahead. Okay, now uh, for after defining the study, what we need to do, that we need to apply any material to this part. Okay, so for that we need to right click on the part, and we have various materials that are predefined in SolidWorks library. You can see here these are a number of metal parts which is as per the standard AI design beam standard is already there in simulation library. The steel, iron, aluminum, copper, titanium, and zinc. These are the popular metal which are used in various operations. As well as in the simulation, the non-metal part is also there, like plastics, glass fibers, rubber, silicons, woods. Okay, these are the different parts. There's non-metal parts are also there. Okay, and if you have a customized part, then you customized material, then you can use at this step. Okay, you can define your own way. Okay, so what I am doing, that I am applying the alloy steel. You can see the various material property. Okay, at here, and I have applied and closed. You can see here the material has been applied. Okay, alloy steel. Okay, the next thing is connection that we are not considering as it is a part. If it is assembly, then we need to use the connections. Okay, now the other thing is the fixture. Okay, so we need to use the fixture. Okay, so just right click on the that part, and you have a different type of features that we already discussed. So it is a fixed geometry. What we will do, that we will select a particular edge which is fixed. Okay, face. Here I have selected this face as a fixed geometry. Okay, then okay, okay. So you can see here the fixture is applied. Okay, now in external load, what I'm going to do, there are various type of external load that we discussed. That is force, torque, pressure, gravity, centrifugal load, bearing load. Okay, you can define the temperature load also, and you can define the free-step displacement also. Okay, you can apply the remote load and mass and distributed mass, etc. Okay, what I am doing, that I am applying a force on this small holes. Okay, one, two, three, and 4. Now, if you can see, the force is applied tangentially, but I want to apply as a normal in normal direction. So, what will I do? That I will select a direction. Okay. Then, when I choosing the direction, I need to define a particular geometry. Okay. So, what will I do? That I will choose the top plane. Okay, top plane. Okay, and I am going to apply normal to the plane. Okay, this is normal along with the direction 1. This is this part. Okay, direction 2, that is this direction, and I am using normal plane, and I am defining the value, that is 1 kilonewton, that is 1000 newton. Okay, now if you can see, the force is applied, but in the upper direction, in y direction. If the force is applied the downward direction, that is minus y direction, I just select this reverse direction. So force is applied on this edge in the reverse direction. Okay, then I need to select it. Okay, so the boundary condition is totally defined. Okay, uh, at this, this is a fixture, this is the loading condition, and what should I do then? Meshing part. Okay, so right click and create mesh. Okay, now you can see here it is a, this tab is shown as the mesh density. Okay, if you select the caution part, okay, and just okay, you can see here the object is divided into large element. Okay, so it will give you more approximate result. Means the result deviation can be comparatively high. Okay, if you want to get the precise result, then you should use the smaller element. But it is not in the case that every time you get the with the small elements you get the better result. Okay, so what I'm doing that just remove this thing, delete part, and I will take the default mesh. Okay, that is not too small or not too coarse. Okay, so I just use the default mesh size. So here is the my discretization has been done. So you can see here the tetrahedral elements is completed. Okay, if you want to see how it is actually divided, so what should I do? That I right click on this quality mesh part and mesh section. Okay, so this is the section among the front plane. This is the section across the top plane that use upward and downward. Okay, this is the top plane part. I hope you can see properly. Okay, and you can see on the right plane how the mesh is actually divided. Okay, I hope you can see properly. Okay, now what will I do? That I just run the solver. Okay, so this is the thing. Run this study. So my linear static study is calculated. Now, if you can see here, the results post processing part. I can see the results. That is the stress, one machine stresses. Okay, displacement part and the strain part. Okay. Now, if you want to animate this thing, you can just right click and say how the actually part is behaving and how the stress is developed. Okay, and by double clicking this thing, you will get the deformation in terms of mm. Okay, if you want to animate this thing, you will right click and animate. Okay, now if you can see here, the maximum deformation is take place at the this boundary. Okay, just opposite to the fixture thing, and vice versa, the one message species is generated maximum on the fixed side. Okay, now, at the post-processing thing, the simulation has been completed. The main thing that manager wants this all stuff into the report. So SolidWorks has a tremendous facility. This is the tab by which you can generate the report. You just to simply click the report part, and what you need that you just click this thing and just publish that thing, so it will automatically generate a report. It is not visible, I suppose, in your case, but it is there in my computer. Let me just reshare my screen. Okay, the report has been created. Okay, you can see here it is generating right now. Okay, and this is the document part. You can just edit by just clicking this thing. Okay, here is the total report that has been created. These are the very assumption, the model informations, then study properties, and units, and material properties that we have applied the alloy steel. Okay, then fixture part, where is the fixture is applied, the forces, the value of the forces, and other contact information, mesh details, and at last we got the results. Okay, in terms of the reaction forces, reaction moment, free body forces, and we have the study result also. Okay, in terms of one-man stresses and displacement and strain. Now, if you can see here, at last the conclusion is also mentioned, but there is no conclusion. Why? Because simulation is a tool. It will provide only the visual image, or say the virtual experiment, but you need to interpret whether what is the meaning of that result, what is the actual meaning of the result, technical perspective of the result. So that can be decided by an expert only. Okay, so accordingly you need to write down the conclusion. Okay, what the study is interpreting. Okay, now let me just come back to the presentation. If my screen is visible. Okay. Okay, so the demonstration is complete. Now let's summarize the webinar. So every company want to grow, expand, and increase its market share. Okay, so with the help of simulation, uh, any company can reach this goal by enabling to develop the various innovative products using simulation, to reduce the development cost, to achieve product performance and sustainability goal, to deliver high quality products in a timely manner, and provide value, higher value at lower cost to their customer. Okay, so I'm going to show the SolidWorks simulation product portfolio. So basically, SolidWorks simulation should consist to main five products. That is SolidWorks simulation, that is the structural part. Then SolidWorks flow simulation, that is the CFD part. SolidWorks motion part, in which you can animate the products, you can use calculate the various forces and torques and all stuff. Then SolidWorks plastic, in which you can simulate the plastic injection process, and you can predict the various defects. And SolidWorks sustainability part. Okay. Now, if you go ahead, then this is the SolidWorks structural simulation. It has categorized into three further parts. That is the simulation standard, simulation professional, and simulation premium. So, as per the package, you can perform the various type of structural analysis. Okay. Similarly, in SolidWorks Flow simulation, you can perform various type of flow analysis, uh, flow analysis, to, which can be enhanced by the another packages, which is electronic pulling and HVAC. Okay. Now, SolidWorks plastic injection is also categorized into three parts. That is plastic standard, plastic professional, and plastic premium, by which you can perform various operations and prediction in the plastic part. Okay. Now, the seminar is concluded here. We are open for question and answer. So if you have any question, please unmute yourself and you can ask the question. Please. Anyone want to ask the question? Okay, so I think there is no question.
So
So,
I have a one question, sir.
please, please.
Can simulations tell us if we want
Yeah,
to design?
sorry to interrupt you, but can you speak louder?
Yeah, now I'm audible. Correct.
You're
Okay.
audible.
So
Hmm.
I'm asking that if I design a plastic cane or something pipe type of thing
Hmm.
and want
Hmm.
to test by the simulation whether the fluid is leaked or not, how can I do this with the simulations?
You need to use flow,
Okay.
the SolidWorks flow. By using the SolidWorks flow, you can simulate the part, and you can simulate that operations.
So, as you saw us that you have removed the uh, fillet and all from the design to the
Hmm.
normal design.
Hmm.
So I need to do this with my finished design to the before the simulation starts.
See, it is the idle procedure that will help you to reduce the mesh size. Otherwise, what happened in that fillet, the smaller mesh size is created, and that will lead to increase the computational time. Okay, and that will not the but obvious there are difference in the result, but that the difference is negligible. Okay, so to accelerate the process and to reduce the computational load, we are doing this process. So it is the standard say procedure that FEA engineers are using. Okay, because there are no much difference in the result.
Okay, so we can use the finished product for the
Yeah, you
simulation.
can directly use it, but the computational time is drastically increased.
Oh, it depends on the system configuration also whether the time communication computation time is increased or not.
Yeah, but
That's
it depends on the number of mesh. Okay,
okay.
so when you are using the mesh, the if the geometry that I have shown in the demonstration is have a simple geometry, so it have a small number of mesh. But that I take in case study, then it have millions of elements. So the computational time is goes up to in terms of days or say weeks. Okay.
Okay, I have last questions. Can I connect in future for any doubts if I feel and face while simulating the?
Sure, sure. Anytime I have uh, uh, displayed the phone numbers and emails. Okay, you can connect us at any time. We are always support the potentials industries and say designers. Okay, so you can connect me us anytime.
Okay, thank you, sir.
Okay. So any more questions? Okay, so we conclude the webinar. Thank you, everyone. Thank you for being patient with me, and thank you for supporting. Okay? Please, we will provide one feedback those who are attending the seminar. So please in on WhatsApp. Okay. So please provide us the feedback so we can improve this thing, and we will discuss in the other aspects of the simulation in future. Thank you, everyone. Thank you. You may leave now.